Alright, so this is standard GG63. It's in the coordinate geometry unit. The standard says determine whether two lines are parallel, perpendicular, or neither, given their equations. So our essential question is, how do we determine whether two lines are parallel, perpendicular, or neither, given their equations? We have 7 important facts to cover. The first is that two lines are perpendicular if their slopes are negative reciprocals. Okay? The negative reciprocal of a fraction is when you flip the fraction and change its sign. If you multiply the slopes of perpendicular lines, you get -1. Two lines are parallel if they have the same slope. Two lines are the same line if they have the same slope and y-intercept. Two lines are neither parallel nor perpendicular if their slopes are not equal nor negative reciprocals. Two lines intersect at an angle other than 90 degrees if their slopes are neither parallel nor perpendicular. So the procedure to follow for the following problems is outlined here in 5 steps. Step 1 is to put any equations or all of the equations in the question and the answers into y equals mx plus b form. Okay, any equations that are already in y equals mx plus b form can be left alone. The reason that we do that is because we want to be able to pull out the slope, and you can't pull out the slope unless the equation is in y equals mx plus b form. By the way, m is the slope and b is the y-intercept. Step 2 is to write down the slope m of each equation underneath the equation, and if it is not a fraction, then rewrite it as a fraction. Step 3, write down the negative reciprocal of the slope underneath each slope. Step 4, use the facts above to answer the question. And step 5, check your answer by graphing the two lines on the calculator. So let's solve some of these problems. I'll show you the example, you'll do the checkpoint. Okay, make sure you put your name on all these pages, by the way. So example 1 says, are the lines 3y plus 1 equals 6x plus 4 and 2y plus 1 equals x minus 9 parallel, perpendicular, the same line, or neither parallel nor perpendicular? So the first step, remember, said put all the equations in y equals mx plus b form. So I'm going to take my first equation, 3y plus 1 equals 6x plus 4, and I have to put that in y equals mx plus b form. So first I'm going to subtract 1 from both sides. That gives me 3y equals 6x plus 3. And then I'm going to divide everything by 3 to get rid of that 3. And what I end up is y equals 2x plus 1. Okay? Now let me take my other equation and do the same thing. 2y plus 1 equals x minus 9. Let's subtract 1 first. So I got 2y equals x minus 10. Divide everything by 2. I don't want to cross those out. Even though they do cancel out, I'd rather leave the division ones without a cross. So 2 over 2 is 1, and 1y is just y, equals. Now remember, there's a 1 in front of that x, so this is really 1/2 x minus 5, because 10 divided by 2 is 5. So that's step 1. They're both in y equals mx plus b form. Step 2 is to write down the slope underneath the equations. Remember, the slope is what's next to the x. So the slope for this one is 2, but I want to write that as a fraction, so 2 over 1. And the slope for this equation is 1/2. Okay? Now, I also, underneath those, want to write down the negative reciprocal. So the negative reciprocal is -1 over 2 for this one, and the negative reciprocal is -2 over 1 for this one. Alright, so let me look at the slopes then. The two lines are perpendicular if their slopes are negative reciprocals. Well, if the negative reciprocal of this line, -2 over 1, if their slopes are negative reciprocals, Okay, so this 1/2 would have to be negative 1/2, which it isn't. And this 2 over 1 would have to be negative 2 over 1, which it isn't. So the slopes aren't negative reciprocals. They're close. If one of them had a negative sign, then they would be, right? But they have the same sign, so they're not negative reciprocals. They are reciprocals, but they're not negative reciprocals. If two lines are parallel, they have the same slope. These lines don't have the same slope. Okay, so then our last option is the two lines are neither parallel nor perpendicular if their slopes are not equal nor negative reciprocals. So the answer to this one is neither parallel nor perpendicular. Neither parallel nor perpendicular. That's the symbol for parallel, that's the symbol for perpendicular. Okay? So you can solve that checkpoint problem on your own. Alright? You can turn that page over, and on the back we have example 2. Are the lines represented by the equation y plus 1/2 x equals 4 and 3x plus 6y equals 12 parallel, perpendicular, the same line, or neither parallel nor perpendicular? So let's put them in y equals mx plus b form. This is y. This says y plus 1/2 x equals 4. So what I'm doing is subtracting 1/2 x from both sides. Okay, that will cancel those out, and I'll have y equals, remember to put the x term first, so negative 1/2 x plus 4. Now I'm in y equals mx plus b form, and I'm going to do my other equation. 3x plus 6y equals 12. I can subtract 3x from both sides. That will give me 6y equals negative 3x plus 12. Divide everything by 6. And y equals, now negative 3 over 6, you have to reduce that. Okay? So that would be negative 1/2. And if you want to see a shortcut on how to do that, right? If I had negative 3 divided by 6, I put that in my calculator, push enter, and it comes up as a decimal, but I can turn that back into a fraction by hitting math. Let me move this up. I hit that math button right there, and now look, that says frac. That means fraction, so I hit enter and then enter again, and it gives me the reduced fraction of negative 1/2. So this is negative 1/2 x plus 12 divided by 6 is 2. If you did that on the calculator, you'd see that 12 divided by 6 is 2. So, let's look at our slopes now. That's the next part. The slope for this one is m equals negative 1/2. And the slope for this one is m equals negative 1/2. The slopes are equal, so the lines are parallel. Okay. Now, you also have to check to see if it's the same line, because if the slopes are the same and the y-intercepts, that's the b part in y equals mx plus b, if those are the same, then it would also be the same line, but plus 2 and plus 4 aren't the same. Okay? Now before I get ahead, I want to show you how you check this on the calculator. Alright? So, I have this equation and this equation. Alright, I'm going to plug them both into my calculator. I hit y equals, and I have y1 equals, that's where I put negative 1/2 x plus 4. But put the negative 1/2 in parentheses, negative 1/2, close the parentheses, x. See the x right there? Push x, plus 4. And then I go down, I hit the down arrow, and I'm going to put in my second equation. Negative 1/2 x plus 2. And then I just hit zoom. See the zoom button right there? And I go to z square. Okay, z square. And I hit enter. And it's going to draw the lines for me, and you can clearly see that those lines are parallel. Okay? Or, I mean, you can't be 100% sure by that picture, but given the fact that you got your answer said parallel and the lines look parallel, you're probably right. Okay, so that's a way to check. Now you can do checkpoint 2 on your own, but let's go back really quick to the first example, and these lines were neither parallel nor perpendicular. Let's see what this comes up as on the calculator. So I'm putting in y equals, I'm going to clear those two. I'm going to put in 2x plus 1, go down and put in 1/2 in parentheses x. Always put your fractions in parentheses. 1/2 x minus 5. And let's see what happens. I hit zoom, and then I hit z standard, or I can just hit the number 6, which is z standard. And you can see that those lines are neither parallel nor perpendicular. Okay? So, let's move on to the next page. Example 3. If two lines represented by the equation x plus 6y equals 12 and 3 times the quantity x minus 2 equals negative y minus 4 are graphed on a coordinate plane, would they be parallel, perpendicular, the same line, or neither parallel nor perpendicular? So I follow the same process. Even though this question is worded a little differently, it wants to know, are these two lines parallel, perpendicular, the same line, or neither? So first I got to put them in y equals mx plus b form. By the way, you can't graph these lines on the calculator until they're in y equals mx plus b form. So no matter what, you have to put them in y equals mx plus b form first. So I'm going to subtract x from both sides. So 6y equals negative x plus 12. Divide everything by 6. Y equals, remember that's a 1 in front of that x, so that's really negative 1/6 x plus 2. Okay? And my slope is negative 1/6. Now let me, that's what's in front of the x, that negative 1/6. Now let's do the other one. This one looks worse, but it's really not that bad. You know how to do this. 3 times x minus 2 equals negative y minus 4. First we distribute. So 3x minus 6 equals negative y minus 4. Then I'm going to add 6 to both sides. And I have 3x equals negative y plus 2. Now I want my y on the left, so I'm going to add y to both sides. Okay, I have now y plus 3x, or 3x plus y, it doesn't matter, it's the same thing, equals, the y is canceled, so that equals 2. Now I want to get my 3x onto the other side, so I subtract 3x. But remember, I want to put my negative 3x first, and then my positive 2 second. So my slope here is 3, but I write that as a fraction. I mean negative 3. So I have to write negative 3 as a fraction, so you just put it over 1. Okay? Now, you can see that those slopes are not equal. Okay, so it's not parallel. Those slopes are not negative reciprocals either. Okay, if these were negative reciprocals, they would be the exact same thing, but one of them would be flipped over and would have a different sign. Okay, so this one would have to be 6, or this one would have to be 1/3. All right, and they're not negative reciprocals. So, and then they're obviously not the same line, because if they were the same line, they would have to have the same slope and the same y-intercept. And look, they do have the same y-intercept, but they don't have the same slope. Okay, so again, this one is neither parallel nor perpendicular. And let's check that. Okay. Now, I go to y equals. I clear both of those. I put in the y equals mx plus b equation, the one that I did. Put the fraction in parentheses. 1 divided by 6x, negative 1 divided by 6x plus 2. So that's negative 1/6 times x plus 2. And then I put this one in there. This one I don't need to put in parentheses because it's not a fraction. So negative 3 times x plus 2, or negative 3x plus 2. I hit zoom. And this time I'm just going to hit the number 6 for z standard. Okay, and you can see that those lines are not parallel and they're not perpendicular. Okay, so we can be confident that our answer is correct. You can do checkpoint 3 on your own. On the back we have example 4. Determine whether the two lines represented by the equation y equals 2x plus 3 and 2y plus x equals 6 are parallel, perpendicular, or neither. Justify your response. So this time we have to write a little statement at the end, okay? But we have to show the same work. So first I have y equals 2x plus 3. And what's really nice about this is that it's already in y equals mx plus b form. So my m is right there, but I write that as a fraction, so 2 over 1. Okay? Now, let me write down my other equation, 2y plus x equals 6. Alright? So we have to put this in y equals mx plus b form. So first I'm going to get the x over to the right side. 2y equals, put the x first, so negative x, and then my number 6, positive 6. Then I have to divide everything by 2 so I can get the y by itself. So I have y equals, remember that's a 1 in front of the x, so that's really a negative 1/2 x plus, and 6 divided by 2 is 3. So here is my slope, negative 1/2. Now look, this fraction is this fraction flipped and the sign is changed, right? When you flip them and change the sign, that means that they are perpendicular. And those are called negative reciprocals. Okay? So, here's my justification. Since the slopes are negative reciprocals, you know what though, when you're writing a justification statement, you really have to spell it out. Negative reciprocals. Reciprocals means the fraction flips, and negative means it changes the sign. It doesn't mean it goes negative. Okay? If it's positive, it goes negative. If it's negative, it goes positive. It means that the sign gets negated or changed. So since the slopes are negative reciprocals, the lines are, and you can put the symbol for perpendicular. Okay? Now, let's check this out on the calculator to make sure it looks like they're perpendicular. My first equation is 2x plus 3. My second equation is negative 1/2 x plus 3. So that's negative 1/2 in parentheses x plus 3. Let's graph those. Hit zoom and then 6 for z standard. Well, those don't look that close to perpendicular, but unfortunately that's because the calculator is a little bit messed up when it comes to graphing things, and they don't really look perpendicular sometimes. Let's see if we can get a better view maybe. If I go to, let's try z standard. Well, that looks a little better, but they still don't look that good. See, if you look at the y-axis, right? Look how close the little tick marks are on the y-axis, right? On the x-axis, they're further apart. So that means that the graph is going to be a little bit distorted looking. Okay, so in fact, these lines are perpendicular, but they don't look like it on the graphing calculator. This is one of the limitations that the graphing calculator has. Now, the reason why I was having you go to z square, oh, you're supposed to go to z square, not z standard. Okay, z square. That should fix it. Yeah, that's what I meant to be telling you the whole time. See, now those look perpendicular. You should be going to z square, because then look now, all the tick marks are the same distance apart. Okay? So z square. So that one checked out. You can do checkpoint 4 on your own. Take out the next sheet. Let me sharpen this. Alright. So, example 5. Two lines are represented by the equations x plus 2y equals 4 and 4y minus 2x equals 12. Determine whether these lines are parallel, perpendicular, or neither. Justify your response. So this is almost the exact same problem as the last one. Let's do our math here. Get them in y equals mx plus b form. Let's get the x over here. 2y equals negative x plus 4. Let's divide everything by 2. So we got y equals, remember that's a negative 1/2 x plus 2. Here's my slope. M equals negative 1/2. Let's write the second equation. 4y minus 2x equals 12. Add 2x to both sides. 4y equals 2x plus 12. Divide everything by 4, and you get y equals, look, let's do that trick again. If I do 2 divided by 4 and I want to reduce that, I just hit enter, and then I hit math, and then I hit enter, enter, 1/2. So y equals 1/2 x plus, and then if you did 12 divided by 4 on the calculator, you would get 3. So the slope of this line is 1/2. Now those are not equal and they're not negative reciprocals. Okay? So again, these lines, so since the slopes are not equal, and because if they were equal they would be parallel, so they're not equal and they're not negative reciprocals, that means they're not perpendicular. So therefore the lines are neither parallel, remember that's a symbol for parallel, nor perpendicular. Let's check. Y equals, clear, clear, negative 1/2 x plus 2. And then I have 1/2 x plus 3. Remember to put your fractions in parentheses. Now we hit zoom, and z square is what we want to go to. So 5z square. And you can see they're not parallel and they're not perpendicular. Okay? So this is the justification for that one. You can do checkpoint 5. Okay, here's example 6. It's a little different, but not really. The equation of line K is y equals 1/3 x minus 2. The equation of line M is negative 2x plus 6y equals 18. Are lines K and M parallel, perpendicular, or neither? Justify your response. So really it's the same problem. They're just naming the lines K and M. That doesn't make any difference. So we write down the first equation, y equals 1/3 x minus 2. Look, the slope's right here. It's already in y equals mx plus b form. So m is 1/3. Let's take the other problem. Negative 2x plus 6y equals 18. Let's add 2x to both sides, and we get 6y equals 2x plus 18. Now let's divide everything by 6. Y equals, let's do that trick. 2 divided by 6, enter, math, enter, enter, 1/3. So 2/6 is the same thing as 1/3 x plus, if you did 18 divided by 6, you would get 3. So here's the slope in this one. M is 1/3. Look, the slopes are equal. So since the slopes are equal, the lines are parallel. Okay, let's check to make sure this makes sense. Okay, cleared. I'm going to put in the first equation, put my fraction in parentheses, 1/3 x minus 2. Go down, put in the mx plus b form of my next equation, 1/3 x plus 3. Hit zoom, and now I'm just going to hit the number 5. And you can see that those lines definitely look parallel. Okay? Do checkpoint 6 on your own. Okay, then we have problem 7. Two lines are represented by the equations negative 1/2 y equals 6x plus 10 and y equals mx. Okay, so for which value of m will the lines be parallel? So they want to know what value of m will make this line here parallel to this one. Well, let's put them in y equals mx plus b form. Negative 1/2 y equals 6x plus 10. Now, to get rid of that fraction, what you do is you multiply everything by the reciprocal of that fraction. And the reciprocal of a fraction means you just flip it over. So I have to multiply negative 2 over 1 is the reciprocal of that fraction. So I'm going to multiply that by negative 1/2 y. Okay, then I have to also multiply it, negative 2 over 1, times my 6x, and I have my plus, and I also have to multiply negative 2 over 1 by my 10. Alright? So all I did was I multiplied negative 2 over 1 by everything in my equation, and that will get rid of that negative 1/2. Because remember, what you do to one side, you have to do the other side. It's kind of like when you divide everything by a number. Okay? This is how you get rid of a fraction. Because look what happens. Negative 2 times negative 1 is negative 2. Is positive 2. And 1 times 2 is 2, and 2 over 2 is just 1. So all you're left with is y. And if you wanted to look at that on your calculator, you can. Negative 2 divided by 1 is the first fraction, times negative 1 divided by 2 is the second fraction. And that's 1. So that's just y equals negative 2 times, now remember this is 6 over 1, right? So we multiply the tops, which is negative 2 times 6x. That's negative 12x. And then I multiply the bottoms, but 1 times 1 is just 1, so I don't need to do that. Plus, same thing, this 10 is really over 1. I multiply the tops, negative 2 times 10 is negative 20, so instead of a plus, I have minus 20. And that's over 1, because 1 times 1 is 1, but I don't have to put that. Okay? Now, let's see. Now I'm in y equals mx plus b form. So my m is negative 12. If I want the lines to be parallel, this slope has to be negative 12. So for y equals mx, I would have to have y equals negative 12x. Okay? So this would be the m I would need, and this would be the equation. Now let's see if those lines come up to look parallel. So this is the first one, negative 12x minus 20. Make sure, by the way, when you are doing negative, you hit a negative sign, right? Negative 12x minus, see now I hit the minus sign, and it even looks different. See? The negative sign is smaller and up higher. The minus sign is longer and in the middle. So negative 12x minus 20. That's my first one. And then I have y equals negative 12x is my second one. Zoom 5 for z standard. And you can see that those lines look parallel. Okay? So you can do 7 on your own. Let's look at problem number 8. Which equation represents a line perpendicular to the line whose equation is 2x plus 3y equals 12? And then we have 4 choices here. Now, none of these are in y equals mx plus b form, so we have to put all of them in y equals mx plus b form. And then we have to look at their slopes to determine which one is perpendicular, which ones are perpendicular to the original. Okay? So here's my original, 2x plus 3y equals 12. Let's subtract 2x from both sides. I have 3y equals negative 2x plus 12. Divide everything by 3. Y equals negative 2/3 x plus 4. So here's my slope. M equals negative 2/3. So I'm looking for the answer that's going to give me the negative reciprocal of that slope because it has to be perpendicular. Okay, so let's do choice A. It's 6y equals negative 4x plus 12. All I have to do is divide everything by 6, and I get y equals, now let's do negative 4 divided by 6, then I want that to be a fraction in simplest form, so math, enter, enter, negative 2/3. Negative 2/3 x plus 12 divided by 6 is 2. So here my m is negative 2/3. Now the slopes are the same, but this doesn't say which equation represents a line that's parallel. Okay? You could see why they put this choice there, because they want you to make that mistake. But we're not looking for the same slope. We're looking for negative reciprocals. So let's look at B. Let's put a little dividing thing here. 2y equals 3x plus 6. All we got to do is divide everything by 2. And we get y equals 3/2 x plus 3. So in this one, my m is 3/2. Check it out. Okay, these two fractions, this one is just the negative reciprocal of this one, or they're negative reciprocals of each other, right? You just flip one of them and negate it, and you get, if you flip this and negate it, you get this. If you flip this and negate it, you get this. So it looks like B is our answer, but we need to still check C and D. Okay, just to make sure that we're not doing anything wrong here. 2y equals negative 3x plus 6. Divide everything by 2, and we get y equals negative 3/2 x plus 3. Now that's close, right? Those fractions are flipped, but the sign didn't change. Okay? The sign did not change. So let's do the last one now. Let's do it underneath. Here's D. 3y equals negative 2x plus 12. I just divide everything by 3. Y equals negative 2/3 x plus 4. Here my m is negative 2/3. And it's the same again. Okay? But that's not what I'm looking for. So it looks right now as my choice is going to be B. But let's graph them and make sure. So first I'm going to graph my original equation right here, negative 2/3 x plus 4. In parentheses, negative 2 divided by 3, close the parentheses, times x plus 4. Go down and graph choice B, because that's the one we think our answer is. So 3 divided by 2 in parentheses, and then the x, and then plus 3. Now we got to hit zoom and then 5 for z square. And you can see that those definitely look like they're perpendicular. Okay, so we can be confident that we made the right choice. You can do checkpoint 8 on your own. Here's example 9. What is the equation of a line that is parallel to the line whose equation is y equals x plus 2? So again, this is like the same thing, but look, parallel this time. Parallel, so we're looking for the same slope. Here's our original, y equals x plus 2. Our slope is, there's a 1 in front of that x. So our slope is 1. Okay, and we don't even have to write that as a fraction because 1 over 1 is just 1. So we'll be able to identify that. Plus, if you're looking for a parallel line, you're just looking for a 1. Right? You're not looking for the negative reciprocal, so you don't really need to turn that into a fraction anyway. So, let's do it. Choice A. X plus y equals 5. Subtract x. Y equals negative x plus 5. What's my slope here? It's negative 1. But I'm not looking for negative 1, right? I'm looking for positive 1. So let's see what B has. 2x plus y equals negative 2. Actually, let's put them as fractions, because I want to show you something. Look, those are negative reciprocals, right? If you flip 1 over 1 and change the sign, you would get negative 1 over 1. So if we were looking for perpendicular lines, choice A would be the answer. But we're not looking for that. That's why they put choice A in there, though, to try to catch those people who didn't know that parallel lines have equal slopes. Okay? So let's subtract 2x. And what we get is y equals negative 2x minus 2. And your slope is negative 2. Well, those aren't, well, let's put it as a fraction, negative 2 over 1. Those are definitely not equal, and they're not negative reciprocals. Y minus x equals negative 1, so this is C. Add x to both sides. You get y equals x minus 1, and your slope is, what's in front of that x? It's a 1, or 1 over 1. So it looks like choice C is going to be our answer, but we have to check D also, just in case we make a mistake. Y minus 2x equals 3. Add 2x to both sides. Y equals 2x plus 3. My slope is 2 over 1, and that is not the same thing, and that is not a negative reciprocal. That is nothing. I'm looking for the ones that are the same, so it's C and C. Now let's graph it. y equals, let's clear those. The first one is y equals x plus 2. The second one is y equals x minus 1. Hopefully these are going to be parallel, so let's hit zoom and then z square, so choice 5. And they are parallel. Okay? Now let me really quickly, let me just show you why, again, we have to hit zoom z square. Okay? If I was going to graph a circle, oh, never mind, it's not worth showing you that until we get to the circle section. But anyway, always remember not to hit graph. You want to hit zoom and then z square. Okay? Number 5, z square. So that's 9. You can do checkpoint 9 on your own. Then the last problem for this assignment. Example 10. Which equation represents a line parallel to the line whose equation is 2y minus 5x equals 10? And you have these choices. So it's the same type of problem, right? Let's see. 2y minus 5x equals 10. First we add 5x to both sides. And we get 2y equals 5x plus 10. Then we divide everything by 2, and we get y equals 5 halves x plus 5. So our slope is 5 halves. And we're looking for a parallel line again, so we're looking for the same slope again. Let's look at choice A. It's 5y minus 2x equals 25. Add 2x to both sides. We get 5y equals 2x plus 25. Divide everything by 5. And you get y equals 2/5 x plus 5. So my slope is 2/5. They're not the same. They're not negative reciprocals either. They are reciprocals, but they're not negative reciprocals. So they're not. That one's not parallel or perpendicular. What about B? 5y plus 2x equals 10. Subtract 2x from both sides. 5y equals negative 2x plus 10. Divide everything by 5. Y equals negative 2/5 x plus 2. Those are negative reciprocals, so these lines are perpendicular. But because here my m is negative 2/5, right? And this one is 5/2. But we're not looking for a perpendicular line, we're looking for parallel. So let's keep going. 4y minus 10x equals 12. So I add 10x, I get 4y equals 10x plus 12. Divide everything by 4. I get y equals 10/4. What is that? Let's find out. 10 divided by 4, enter, it's 2.5. I want that as a fraction though, right? Math, enter, enter, 5/2. Plus 12 divided by 4 is 3. Look at my slope, 5/2. That's my answer, right? They're the same, that means they're parallel. Now, you would have never gotten that if you didn't know how to reduce 10/4. A simple step of just knowing how to reduce a fraction wouldn't have gotten you this answer. Okay? So our answer as of right now is C, but we also want to check D. 2y plus 10x equals 8. So let's subtract 10x. 2y equals negative 10x plus 8, and let's divide everything by 2. Y equals negative 5x plus 4. That means our slope is -5, which is definitely not 5/2, so our choice is C. Now let's graph it to make sure this is good here. Okay? My first one I'm going to graph is y equals, in parentheses, 5 divided by 2, that's 5/2, and then the x, plus 5. Then I go down and I'm going to graph C, which was y equals 5/2, and then the x, plus 3. Also, by the way, notice that they were almost, if that 5 and that 3 were the same, then these would actually be the exact same line, because they would have the exact same equation. They would be two lines right on top of each other, which would be considered the same line. Okay, so the only difference between parallel lines is the y-intercept. The slopes are the same. And let's check that out. Zoom, z². And you can see that those lines are parallel. Alright, so you can do checkpoint 10, and once you've finished that, and your name is on everything, you have finished standard lesson GG 63. Okay, good job.